Hello and welcome to the Dubai campus of Heriot-Watt University. My name is Tyga Donovan. I am the Head of Engineering and Physical Sciences on this campus here in Dubai. And today, and more importantly, I am going to be your tour guide. I am going to take you through all the different workshops, labs, teaching spaces that we have developed as part of this new state-of-the-art campus that support everything that we do in engineering or courses in mechanical, energy, chemical engineering, robotics, autonomous and interactive systems, electrical and electronic, and undergraduate as well as our postgraduate programs in advanced mechanical engineering, energy, renewable energy engineering, and soon our degree program in global sustainability engineering. So come with me as I take you through, as I said, as a tour guide, try to introduce you to as many of my colleagues in the School of Engineering and Physical Sciences who are more expert in telling you how different things and different aspects of this campus are supporting our students to become these graduate engineers. Okay, let's head in. So we have moved, as you will know, from a campus in Dubai International Academic City. And we have done this during the pandemic, which has had its blessings, but also its challenges. And we have been here for about 15 years now, or 15 years in Dubai. So this really is the culmination of about 15 years of delivering high standard of education here. We now take full charge of our facilities, and we've had a really great opportunity to design from the ground up all the facilities that we need to support our full curriculum or the different programs that we have here. So we are split over 6 floors. On the ground floor, as you'll see, I'm about to go into our workshop, our ground floor workshop, which is relatively small, but is used for some niche parts of engineering. And then we'll make our way up through different floors and eventually end up on the 6th floor, where we have the majority of our labs and workshops. Okay, so let's come with me as we go into our workshop. And this is where I'm going to just add some PPE, if you don't mind. Thank you. What's important here, especially in terms of PPE, is the level of access that we give to students. So obviously, different zones will be have different requirements for PPE. This badge that I have, and every student will have, will manage your access and your privileges to different areas. So, for example, a student would have to have gone through all the safety protocols before this card will allow them access to maybe the chemistry lab or the robotics lab or whatever lab that they need to get to. And that's something that we can control, something that on a semester or on an annual basis to make sure that students are, first of all, going through those health and safety protocols and making sure that they adhere to them as well. So, as we go in here, this would be our kind of decompression area. There will be all the PPE here for the students, and they'll be able to leave their baggage where they won't be able to bring that into the workshop. So this would just, we'd have to add in some furniture here, and there'll be a line on the floor that they will not be able to pass until they're actually wearing the correct PPE. We have an office here / store for some of our technical staff. And then the first thing we'll see as we pan around are some of our students. Hello, everybody. We'll talk to you in a minute, but I just want to point to this area first. These are our former students. To this kind of demonstration area. It's a very flexible area with the big flat screen, the podium. It's a place where we hope to actually deliver part of our courses and our curriculum. So it's not a lab that's disconnected from the curriculum, but very much part of it. We're using the space, and what you'll hear a lot of from my colleagues as we go through space to space, they'll be talking about this experiential learning, about the practice-based learning, the learning by doing, learning in the environment, and that's really what's very important to us. So that's why we design these spaces like that. We're going to start by introducing you, though, to Mohammed Al-Musla. I'm going to give you this, Mohammed, and turn it on. Okay, so Mohammed has a number of titles. You are an assistant professor in mechanical engineering. You also lead, and we'll hear more about it in a second, the program in automotive engineering. And you are also line manager, or you oversee, as part of your, what would you say, your collegiate or your administrative role, all the workshop and lab activities that, that happen in the School of Engineering and Physical Sciences. So that was a long introduction, but Mohammed, you might just take us through this first place. We call it our welding workshop, so maybe you could just give us a few minutes on what happens in here.
Well, thank you very much, Ty. This space, as you can see, it's really closed space, no windows there, special exhaust. Students come here to do a metal workshop. They start their first year by getting into here and working with some welding demonstrations, some manual tools, and fabrication using metals. And then they move to turning machines, milling, and so on. All these is based on the curriculum. So these are planned activities, and this will be risk assessed with details. The students will be given a training before they start using these machines. What's also important to mention, this facility is also open for other students. For example, project students or formula students, which we will see in next, if they need to weld something or shape something. They will need to work with our technical team to sort out the health and safety requirements, the risk assessment, and then they will need to carry a mandatory training before use any tools. We also try to maintain a close supervision in this space. There is a technical base down there where we normally, if this is used, the technician and the academic staff will be around. We work with the small groups, normally around three students in a group, so they get to see better what they have to do, and they will get space around them and maintain health and safety.
Excellent. So a couple of the courses here that are supported by this facility would be engineering in context, I think. Some of the engineering
starts there, then design of manufacture.
Design and manufacture.
2, 3, and go on. We got the project for both electrical and mechanical, automotive. The energy students also use the space. And the other courses that this supported also automotive courses where they will get to work with some fabrication.
And perhaps worth emphasizing that the objective of these activities is to give the students some experience, perhaps maybe some insight into how turning works, how a drill press works, how welding works. Not necessarily to make them a master craftsman or woman, but
a certified welder, for example, but they need to know how welding is taking place so they can manage later a team of welders or design for manufacture and so on.
Design for manufacture, not just for function, but for manufacture as well. Exactly right. Cool. That's great. But I believe there are still opportunities for people kind of extracurricularly to get a little bit of extra training so they could become a bit more independent and use these things a bit more autonomously, maybe to support their projects later.
Absolutely. And as this is showing sort of a tight space here comparing a larger project, we do have a larger space to support other projects. So it's all as activity-based, connected together whenever you complete a piece of work or a project.
Excellent. That's great, Mohammed. I think we're going to see you in a second, but are we meeting somebody here to talk about some of the project work that we do down here as well? So this, I suppose, is the workshop a bit more proper. If you come with me, you still have your microphone on. Again, a kind of a flexible zone, but probably mostly going to be dominated by automotive engineering. I know we have a car here in the buggy, and we have the Formula student car there. But also down at the end, and sorry to flip around so quickly for about we put in some of our research projects, or we allocate space when they're trying to...
for larger projects.
Yeah, for larger scale projects to support our PhD students or our engineering doctors students. And I know this one here is part of an Expo funded project. Not always going to look like this. We're still moving in, and you'll probably hear me say this a few times as we go through the tour. We moved onto campus just 4 days ago, so there's a lot of work to do before we welcome most of our students back in September. So, but just in terms of priorities, we would consider this space here to be a small workshop, mostly for automotive. And I see behind we have our...
Yeah, so we are getting a 2-pillar lift exactly here, or maybe like that, to get that recessed in. These doors behind you, they fully open and they like accordion, and then we can get cars in. Yeah. We do work with local entities who build cars.
Yeah.
For example, Ash'ali Motors, we have their prototype here, and we have done some studies for thermal management, for example. The space here is also being used by clubs and
Yes.
teams like Heriot-Watt Racing to build their car, modify it, and work around with all their design aspects whenever they need labs. We do support courses like Automotive Technologies 1, Automotive Technologies 2, in here where we will get through all the system basically of an automobile, and we push it further a bit with today's technology when it comes to remote sensing and other aspects of the current trends in automotive.
So in terms of contextualization and things like that, automotive industry here in the UAE is bigger, there's more interest in it, and it's a program that we have here in Dubai that it's growing over the past few years. Sure. But of course, this facility of automotive engineers is still used by obviously mechanical engineers and others, right? Whether it's the electrical and electronics engineers looking at telemetry. We'll speak later about robotics
and autonomous systems.
Right, and autonomous vehicles and all of that as well. Excellent. I think now we're going to, if you wouldn't mind introducing us to maybe some of our former student team who have been kind enough to give up their free time to join us today.
We have we got the team active in Dubai now, and they are working in collaboration with a global setup really, and I'll just let them talk about that.
Okay, so
Yeah, if you wouldn't mind just introducing yourself and tell us a little bit about the car.
yeah, sure. So I'm Rakshita Chitangia. I'm a representative of Heriot-Watt Racing Club Dubai campus. Heriot-Watt Racing is a global team effort that communicates with the Dubai campus as well as the Edinburgh campus. The Edinburgh campus competes in the Formula Student UK at Silverstone. And both of the campuses are part of the Institute of Mechanical Engineers, which is IMechE. This Heriot-Watt Racing Club is not only for engineers, but it's for all majors in the university. This car is completely student-led and created a fully functioning electric car.
Excellent. So, the thing about Heriot-Watt Racing is, like you say, it's one team, right? Heriot-Watt Racing. You just happen to have, let's say, engineers from Dubai and Edinburgh coming together to design the one car that races in Silverstone. And I don't know whether you know this, but for the past 2 entries, not last year because of COVID restrictions, we've had students from Dubai also travel to the UK to compete as well. So we see it very much as one global team.
Global team, yeah.
Absolutely. And like you were saying, I know this chassis was originally, it's a kind of recycled one, isn't it? Because this one was originally for an IC engine. You can see some of the mounts are still there for the IC engine. But this is our first electric vehicle. I think I've lost Mohammed. This is our first electric vehicle.
So I'll hand it over to Mohammed.
So just like you said, sir, this chassis was originally sent to us from the UK. It was an IC engine chassis. But then here, like in a time of around a year, I say, we managed to fully convert it into an electric-driven car. It's the first ever we ever fully built in Dubai. First ever.
Excellent. Listen, guys, thank you all so very much for your contributions and obviously for running this team over the past few years. It's been absolutely amazing to see the enthusiasm, the success that you've been having. So continued good luck and thank you very much for that. I will see you again later. Okay, so turn this off. We're now going to head upstairs. As I said, our footprint on the ground floor is not huge. It's mostly for large-scale heavy equipment that we simply couldn't house on our facilities up on the 6th floor. So what we're going to do now is we're going to, well, I have to remove my PPE, and we are going to make our way to some of the learning spaces on the 1st floor. Actually, before I get the lift, I might just take a quick look at from bottom to top. So we have come in on the ground floor. We just call it the welcome reception. There's a number of different things here from our town hall that we haven't seen and other facilities for. As we go up, we're going to go to student life now to show off some of the facilities that we have. Then we're learning more of the classrooms, library, maths gym. We'll also touch base there. Skip the staff zone. Design, we could go to, it certainly supports some of our engineers, but it's predominantly used by our architects and architectural engineers and interior designers. And then we'll get to the enterprise zone, and then finally we'll finish in discovery. So yeah, let's head upstairs. Okay, so we're in the first floor now, and I'm joined by
Hello.
Dr. Mehdi Nazrinian. Now, Mehdi has a number of hats that he wears here. He's currently our Director of Academic Quality, but for the purposes of today as well, you're kind of going to be taking the role, your former role, of the
Director of Learning and Teaching.
the
for
Associate
Dubai
Director.
campus.
The Associate Director of Learning and Teaching. So maybe before we do though, if you could explain that role of DAQ and what you do in that role.
Yep. The role that I took up a couple of months ago is the Director of Academic Quality for the whole school, and that's actually for all of the programs that we are actually delivering across all campuses. It's not only engineering; it's physics, chemistry as well. And what I'm actually responsible for is really the academic quality of all of those programs.
Yeah.
It goes from disciplinaries all the way to partnership agreements with all the partners that we have. And it's all about ensuring that we are sustaining the high quality.
Yeah, and I mean, we have this kind of one Heriot-Watt kind of approach to everything that we do. So as this kind of, I won't say campus, but as this university has matured here in the UAE, what we've seen obviously is a lot more leadership coming from this campus, and you're a classic example of that one there. Your role is not, and we'd like to emphasize this, is not at all restricted to Dubai, but actually across the whole school that covers a lot of programs that we don't even deliver here in Dubai. So where are we now? We are in one of the, I guess it's the cafeteria.
Cafeteria, it's really for everyone, but mainly for students to sit here. There are some classrooms, as you can see around. There's going to be cafeteria opening here. There's some common group study rooms. In fact, what we have in this building are the sort of efficient design of this space, if you like, that every corner you go, there's somewhere that is designed for students to learn. This is an example of it. So students can sit here, study, not only within the group themselves here, it's across the campus, collaborations as well. And it's a nice feature because what you can do, either you can, through the resource planner, you can book the room, or you can just come here, you think you want to have a chat, you can just click on the plus. If the room is going to be available, it will bring up the availability. If this one doesn't work, but you can actually choose what time, and you can actually pop in the room, and I can use the room. It's obviously for students and staff.
Yeah.
And we have many of them around the campus.
And probably, the one thing you'll notice as you walk around here is that there isn't a kind of a wasted space.
No,
nearly every space is a learning space.
Yeah.
And I think what we're going to do on this floor, just very briefly, you're going to take us through some of the more innovative teaching and learning spaces.
Yeah, you can refer it to learning and teaching enhanced, technology enhanced active learning space, for example. I'll show you.
Yeah, please.
I think it's easier to actually see. So this is called Collaborative Lecture Theatre. We have two of them in this building. As you can see, it's got a different plan. As a lecturer, when you're in, you can have all sorts of interaction with your student. You just need to touch the screen as a lecturer. It pretty much turns on everything for you. There are, the mic is already on. You can see there are all sorts of various microphones here that you can walk around, interact with your students, and they can interact with you. There are different orientation of the seats, so they can actually work themselves. So it's a really suitable environment for active learning. And that's really what we're doing as a responsive blended learning approach that we have.
I guess it's always been one of the challenges, right? When you have large classes, how do you still make them collaborative? And some of that is the softer design approaches, like these kind of seating arrangements where you're not all facing forward, you're sitting adjacent to each other, you're going to sit in groups, and it's made for large classes, but can still work in kind of small and intimate groups. I know what you're going to show me in a second, but it kind of couples with the AV system, doesn't it? Because there's fully lecture capture pretty much every second.
You can see the black video there. It's actually following the lecturer, and there are obviously white screens that's going to be projected at.
You're going to see if this works?
Yeah, it works, and you can actually talk to the mic, and you can see this actually really friendly environment, so I can actually throw
Sports is
the
not my
microphone
forte.
and then you can start talking to it. So there are various options here so you can use. I mean, this is interesting because you may really don't need to carry your laptop. Everything is on our Office 365, cloud-based system. You can choose how you want to interact, what features you want to use, and it's not actually limited to the face-to-face. At the same time, you can blend it,
Yep.
and you can actually get your students through Teams, for example, to log in online. So you can have both of the activities, and you can cover a wide range of actually activities that you can do.
Yeah, and it's kind of worth pointing out that this was designed from scratch in terms of the number of these types of spaces, the capacities of them to be able to support all the 5 schools that we have
Yes.
here in Dubai, not just today, but looking forward. So most of our labs, as you'll see, they're kind of designed at kind of at about 2/3 capacity. We're projecting growth, or at least investing in facilities that will support a 50% growth in all of our school, at least in engineering and physical sciences programs, which and we've been quite successful in being continuously growing.
I think, Tag, what's important to highlight here is the facilities you see, they're not designed because of COVID.
No, that's very true.
They've been within our strategy from a long time ago, and where we are is the vision of our university.
That's right.
Something we believe should have been or should be embedded into our curriculum and into the way we teach and interact with our students.
That's right. We probably don't have enough time to get into
Yeah.
the intricacies of what RBL, responsive blended learning, is to us and how we do it. But
But at
one
least
thing,
we can show the environment that we have in hand for
and
our
we can show
students to-
how the design is supporting that new way of teaching. And
exactly.
I guess the point you're making is that this isn't a reaction to COVID. This was very planned. It was, as so many things now, have been accelerated due to.
Exactly. Yeah.
Right. Okay. Excellent. Well, you're going to come with me as we go to the kind of the library.
I have got other types of classrooms upstairs in
Excellent.
different floors that I can show you.
Let's do that.
So let's go to the second floor then. Okay, so now I'm going to show you our library facility. This area here that you're going to be seeing is really our
So if you want
library.
to pan around.
Look, it's going to be the help desk section. And again, you can see on your left, there is going to be a lot of other cubicle areas, which I'm going to be explaining in a minute. But I think what I want to show you first is actually our book section.
Collections, yeah.
Yeah. So what you can see here is a collection of all of the hard copy of the books that we have. But obviously, this is not limited to the hard copy. What we have in the university is a discovery system where we have a lot more than what you see physically here, access to journals and ebooks, which are actually accessible to all the students and obviously staff across the globe, whoever is on HW.
And that was important to us as we were designing the campus, right? That, it's kind of designed the library of the future as well. That's going to be less reliant on physical collections.
Yes.
There's always going to be probably a place for them. And you can see multiple copies of some of the core texts that support our curriculums. But, discovery is something we'll probably discuss more in open session, and how it is used much more than anything else. So maybe if you just want to take us around the environment.
You can see there are some stickers. Obviously, that's because of the pandemic restrictions. But there are studying area. These tables are going to be used by students or whoever wants to do a bit of study in the library. So there's still a bit of noise here.
It'd be considered kind of collaborative learning as well, right?
Yes, it can be considered that way as well. So as you can see, there are many of them available for our students. Even what I like is even between the shelves, you can have
Quick
areas
chat,
where students can sit down and look at the books and choose the one that they want, for example. And
maybe as we just
on.
pan across then, I know you've mentioned it a couple of times, but it's like the sheer number of these kind of group study, what we collectively call learning commons, is phenomenal, really. Bookable and non-bookable spaces for students to interact across campuses or just in their projects as well.
In the projects that they're
Right.
working as well. As we're walking around, so you will be able to see more of them in the video.
Yeah.
Every floor that we go, every corner,
Every corner.
the space has been used efficiently, I would say. And a couple of these are actually used and it's bookable by anyone.
Oh, absolutely.
Or
Yeah, yeah.
even students.
So I just in this corner here,
Yep.
apologies to our cameraman Febin, who's doing his best to catch up with us. So it's just worth, I know this is kind of interjecting into your part, Mehdi, but it's a good vantage point for us to just scan over some of the facilities that we have. These are our sports facilities. Again, not supporting the curriculum necessarily, but very important to kind of the student life and student council activities that we do. This is a shared facility. Now that we are in Knowledge Park, we're kind of co-located with a lot of international universities. You can see University of Wollongong there, an Australian university, Middlesex, and so many more in this area. And that is kind of a new sports facility that's going to be shared by the different universities. So you can take it away again there from the library.
Yeah, well, this area here is a library quiet study area. Obviously, we're not going to be going inside and interrupting our students. But this is an area which students can study. It's a very quiet environment for them to concentrate. So if you don't have to work in a group, and that's something that they want to do individually in a very quiet environment, this is what we have provided to them. So it's a large area that students can go and use for their learning and study.
Excellent, thank you very much. So I think we're going to go through now to some of the other facilities in the library that support learning. I think we can close that one. And go to this area here.
Again, yes, the same thing. We can see there are.
So if you
meeting
pan
rooms.
kind of to my right, your left, you'll see, you know, everything is kind of thought as there should be no wasted space. You're either working on your own, you're working in groups. It's to kind of get rid of that rigidity and have a little bit more fluidness or a fluidity to the kind of the discussions and the kind of interdisciplinary nature that inevitably would happen in a library. So you'll see again more and more of these here. So we're about to go into the maths gym, and you can kind of scan across. This is what we'd call part of our learning commons. It still kind of fits as part of the library provision. So you'll see here kind of, you know, what looks like a fairly standard computer room, but again, with these kind of breakout areas to support students in whatever activities that they might want to do. But what we have in this room here is our maths gym. So it's a dedicated space to supporting students across discipline and across programs with just their numeracy, I would say. So I hope, yes, we are. We're going to meet Suri here. Hi, Suri. And if I just take the microphone.
Thank you.
So I'll introduce you to Suri. Suri is an assistant professor mostly in the discipline of electrical, electronic, and computer engineering, but also contributing mostly to the kind of the delivery of maths courses, especially in the early years of undergraduate engineering across schools, actually. My school, or our school, in the engineering and physical sciences, but also to engineers in the School of Energy, Geosciences, Infrastructure and Society. So we have this space here that's dedicated to supporting students as a kind of drop-in center, would you say, for getting maths support.
Yes, yes.
And that could be anybody from any year. So
Yes, yes.
I know you have a couple of slides there that you might just want to present to
Yes,
us, and we can
yes.
see. Yeah.
So welcome. This maths gym is meant not only for EPS, it can be anyone
Yep.
of a Heriot-Watt University. It can be from, students can be from EGs or SOS or DEP, so many different.
That's the School of Social Sciences,
Yes.
the degree entry program,
Yes.
the School of Energy, Geosciences,
Sorry,
Infrastructure
not
and Society.
everywhere. Yeah. Okay.
We use
So-
too many acronyms sometimes.
Yes. So basically, we provide math and statistics help. I want to stress that it is not a traditional lecturing.
No.
Okay, so students will drop in, and we will assist them with their basic knowledge what they have. If they have any difficulties in maths, we support them with extra materials, and we take care 1:1. It's just like 1:1 help for them to better understand the basic goals in the mathematics skills.
So it's kind of you, but you have a team of teaching assistants that
Yes,
would, yeah.
yes. It is not one-man show.
No.
There are, of course, we need many people. There are so many teaching assistants who are assisting me, and it depends on the student population also.
Yes.
Right. So depending on that, we are dividing our work.
Yeah.
And we are conducting this kind of activities. There are particular drop-in sessions wherein students have the opportunity to ask questions related to maths or any topics in maths, okay, and general discussions if they want to have, if they are stuck in some problems or something, they can discuss with us, and as well as some mathematical software usage like MATLAB and math-related softwares like Maple. So these are the two things which we are focusing, and there are plenty of online resources we have produced. We have created a separate course folder on Vision called Maths Gym.
That's our virtual learning environment.
Yes, virtual learning environment platform, wherein the link is sent to all students.
Yeah.
So they can access all these materials. There are so many materials we have put up on the Maths Gym course in the virtual learning environment.
Excellent.
And in addition to this, we are covering range of topics. Like for degree entry program, students may have some difficulty in university entry-level mathematics skills, and our students, EPS and EGs students, will have some basic problems like integration and differentiation stuff. So we are covering basic engineering maths also, what we are dealing, and as well as MATLAB applications. And School of Social Sciences, they want something like probability, statistics, related things for that kind of provision also we are giving in this program.
And you've even had some inquiries from our MBA program.
Yes, yes.
Executive level training.
Students also used very recently this provision. And here in Dubai, I'm managing with the teaching assistants, and in Edinburgh also it is running, and in Malaysia also it is running. We are all in as a team. We are working as a one particular team. Okay, so success story of Dubai is particularly quite interesting because I teach maths, although my background is electrical engineering. I teach maths. Maths is my hobby, and I teach second year maths. Okay, so second year maths interesting story was 2018-19 the pass rate was 72%.
Yeah.
Okay, now once we implemented this, we started this in 2019 September. So it has increased to 86%, 72% to 86% sudden increase in the pass rate. This is the impact what we had in Dubai. And also it has contributed to the increased retention rate, not just in EPS, but in EGs also. So which stands at 90%, which is significantly above the average campus progression rate of 80%.
Excellent.
This is our success story, and our backbone is you, because your door was always open.
We don't need to go.
Yeah.
Thank you very much, Suri.
Thank you so much.
Thank you, and we'll see you later. Great. Okay, so we're going to leave the Maths Gym now. So we just over here. And we're going to head up towards our enterprise hub. The Maths Gym has been really important to everything that we do here. In Dubai, it services a need where it's just some, of the basics in mathematics just sometimes aren't there. Even though we have similar entry standards, we deal with a lot of different curricula. So it's been really important for us to kind of have that foundation or that open door for students who just need that extra little bit of help. And it really is very rewarding to see how they're going. In Edinburgh, it's also part of a kind of a widening participation provision. So it's a real cross-campus initiative that has that really is supporting students on all levels. It wasn't initially intended for like the MBA, but it was kind of one of those, why not? That sounds really good. So we're going to head up now to our enterprise store and talk about, well, let's see when we get there. Okay, so now we've made our way to the 5th floor. It is our enterprise floor. At least that's what we're going to focus on here. I think the actual, yeah, it's called enterprise floor. That's good enough. So as we walk down this wing of the building, we're going to go into one of our kind of business incubator spaces. And we're going to meet one of my colleagues, Muhsin Noor. Here. Excellent. Work first time. Hello, Muhsin. Hi, Olga. I think we'll start with Muhsin. Muhsin, we're in the kind of incubator enterprise hub. Maybe you could tell us, if you take this first,
Yes, we are.
what this space is used for.
Yeah, this business and enterprise hub basically is an incubator for startup and entrepreneurs to relocate and encourages their innovative projects. So basically, also it's a place to connect with our industrial partner. This will give an opportunity or encourage increase opportunities for our students to connect with industry. This will give them a unique experience or learning experience, basically. So here we are also normally conduct the meeting with our industry advisory board members twice a year, and we discussed various topics such as extracurricular activities for industrial visits, industrial visit, guest lectures.
Sure.
Internships as well.
Yeah.
So yeah, this is the space basically to extend with our external community, mainly the industrial advisory board.
I'm a bit remiss, I didn't actually introduce you properly. So you're Dr. Muhsin Noor, and your title, because I know you're part of the management group of the School of Engineering and Physical Sciences, and you're the director of?
Yes, I'm the director of external relations and industry engagement here in the School of Engineering and Physical Sciences, and also I look after the postgraduate programs, Master in Energy and Renewable Energy Engineering as well.
Absolutely. So, one of the fundamental ethos or priorities for Heriot-Watt, of course, is kind of working with industry relevant degrees, kind of enterprise and entrepreneurship, isn't it? And we have this kind of grid philosophy. We have a grid building in Edinburgh. It stands for Global Research, Innovation and Discovery. Yeah. And kind of everything on this campus kind of aligns with that. And this is one of those examples. Yeah. What I like about it is that a student who has an idea, maybe in their first year, just has an idea, they could ask, could they be part of this? And their access key card can be coded to allow them access, and they'd be able to come in here maybe to collaborate, maybe to take that seed of an idea and kind of nurture it a little bit here in kind of, with some business support, with some access to offices and quiet spaces.
Yeah, exactly. That's true. This will give them an opportunity to connect with our industrial partners and business as well. So yeah, that's will give them a great opportunity and great learning experience, definitely, even if they are at first, second, or even third year.
And again, one of the reasons I suppose we moved campuses from Academic City to here in Knowledge Village or Knowledge Park is to be kind of co-located with some of industry here. So we have we're right beside Internet City.
Yeah, exactly. So we are in the middle of, or surrounded with lots of business, actually. It's a happening area. For example, we have lots of companies here in business, different industry which is related to energy, information technologies, and so on. Yeah. So yeah, we are so close to many business opportunities, if I can say, to engage in the future.
So we kind of play that role in kind of incubating small ideas, but also, encouraging industry that align with our curricula and what we're trying to do to maybe, use this space as well and contribute to, everything that you said there, like, student projects.
Yeah, that's the idea. We hope that we encourage industries to come and start their own, even our alumni to come and start their own ideas here in this space and engage with different industries as well. And also at the same time, we can engage our students from different disciplines and years.
Yeah, and staff too, right?
Yeah, and staff, of course. Yeah, definitely.
When we have the time. Thank you very much, Muhsin. I think we're going to go and we're going to meet Olga now. Hi, Olga.
Hello.
Can I have this one? Thank you very much. Here's your microphone. No, it's all good. So, Olga, you can probably introduce yourself, but you're an assistant professor, kind of in mechanical engineering, but you also work on our MSc programs, don't you?
Yes, that's right, yes.
And I think you're going to talk to us about this space behind us. That looks a little busy at the moment, and we're still moving in with boxes, but it's kind of our showcase area, and particularly the course in business awareness, safety, and sustainability.
That's right. Yes, that's the course that.
Over to you. Let's go in. Let's barge our way in. I think we can. Oh, I need to press the button. Off you go. So this area here is, I don't know, do we call it the gallery, or it's kind of a showcase, kind of an events area?
Display area, yes, but this area is going to be great for our poster exhibitions, and one of the poster sessions that we're running every year is for our business awareness, safety and sustainability course, which is based on engineering for people design challenge.
Right.
So the students are given a design brief, which is based on a real world problem on the location that can be picked anywhere in the world, and the students need to find the solution in the environmental, social, and economic context of that particular location.
So not just technical.
Not just technical, it also teaches them to look at other aspects and demonstrate that they can apply their skills and take account of the local context and learn to communicate their design work in a team, and also manage the project, manage the finances, and manage the marketing.
So one thing I like about this course is that it is kind of multidisciplinary. Like all our students, and I think it's probably one of the defining things about a Heriot-Watt degree, that it's not just technical. It obviously has that business side and the social side. But when you create groups in this, you try to bring together multidisciplinaries within the same group, right?
That's right, yes. We're trying to put the students into multidisciplinary teams. So students with the mechanical engineering background, chemical and electrical engineering, they all join together in one team, so they can bounce their ideas off each other and come up with a design that is all-rounded and look at all aspects of the problem.
And I mean, it's non-traditional. It's not really lecture-based, is it? It
is not indeed. The students are asked to provide the solution, and they're doing it as part of the team.
Right.
And their report is then submitted to the team and assessed as part of the Engineering Without Borders Design Challenge competition.
And I know you've done stuff with kind of aligning with UN SDGs as well as Engineers Without Borders and all those. Absolutely. And working cross campuses too.
We are working across campuses, yes. Some of our teams actually cross campus teams, and the students from one group can assess the design of the group from another campus. So that teaches them to look at other aspects that maybe they have not really thought of, and that teach them to sort of to account everything in that global context.
And remind me, these are students typically in their third year?
Depending on a discipline, so it will be second year and
for the electrical engineers, and a third year for all the rest of them. That's right. Excellent.
Okay.
Thank you very much for that, Olga. I think we're nearly on the end of this floor, but we're going to now go to some of our computer rooms. Ah, yes, the microphone's been passed. But before we get to the computer rooms and some of our teal rooms, I'm just going to quickly pop into our recording suite. So this was a big ask for us as we were going through the design, and it was actually pre-COVID that we wanted to have this kind of suite of recording studios. We were always moving towards this, what we call responsive blended learning, having much more of an online provision. So we've created these bookable spaces. They can actually be booked by students and staff. So if I go into one of them, we've put in I don't know whether the different acoustic comes up on the audio here, but it is obviously designed to be acoustically very quiet. We haven't got our tech in here yet, but we have 3 of these recording studios for people to come in to record their lectures in or in whatever background or demonstration that they want to have. And it's just something that was so important to how we envisage delivering the curriculum in future, to have so much more recorded content that will support students irrespective of their location of study. So content that's obviously created here in Dubai will support students, independent distance learners, students from Malaysia, Dubai, even Orkney and Edinburgh and Galashiels, or even some of our affiliates further overseas. So we'll now quickly go to one of our computer rooms. Where we're not going to meet Rula. Okay. So this is one of our computer rooms. There's quite a lot of computers in here. With social distancing, I think we're going to be using every second one or in some sort of staggered array. This supports a lot of activity, of course, across all disciplines. Our School of Maths and Computer Sciences have been instrumental into the design of this. And as you can probably work out, this large space can be broken down into 3 different computer rooms for asynchronous or synchronous delivery. It supports a lot of what we do, obviously, across our programs in EPS, whether that's electrical and electronic engineering and all the computer codes that we use in mechanical as well. So yeah, but other than that, it's a fairly standard, if not a significant investment in our IT infrastructure. So I think I'm joined again, now if I can have the microphone. Thank you very much. By Mehdi, who's going to take us through some of the, I'm trying to think of what the acronym stands for, TEAL. I know it's Technology Enhanced Learning. I thought there's another E there.
Well, it should be A for active.
Oh, active learning, TEAL, there you go.
Yeah, so here is actually a very good...
Now these are dotted across the campus, aren't they? But you've just chosen two.
I'm just showing two of them. This corner I think is the best one because we have 2 of them next to each other, so I can actually show you how our other classrooms other than the collaborative learning environments are looking like. So this one is a sort of a traditional type classrooms that we have where you get the desk tables and then the chairs, students. Again, same concept. Every lecturer comes in, has a whiteboard, has a screen. They just need to touch on the screen. Everything's going to be turned on. The mic and the system that I just showed you to the other room. And they can basically start interacting with the students for their learning, whatever that is going to be, either teaching or tutorials. So this is one. Then the next, though, is another type of classroom, what we call a digital classroom. So in addition to what we have here is what you just Tyke said. It's more suitable for technology enhanced learning, active learning. And as you can see, there are different tables around this room. And the beauty of this room is it really makes it a lot easier for collaborative work. Each student, each group of students are going to have their own monitors, if you like, which is standalone for this table. And they can sit here, they can work together. Obviously, the lecturer, the TAs can walk around. And the good thing is you're not going to be limited that you have to stand here to be able to present. You can, through the wireless system that we have, you can connect to individual screens or to the actual main system. So you can actually start walking around. Even you can ask the students to present. Okay, so for this table, you want to present, so you can set it. They can actually enter and project.
That's right. The students can take control.
They can take control. Not only that, but also you can actually have it actually as a cross-campus collaboration as well. Yeah. So you can connect through Teams, or even it's going to be Blackboard, Ultra, Collaborate Ultra, and they can actually use that for collaboration and work on any sort of subject matter that you're discussing.
These are really good. I think this is the kind of enabling technology that really supports our students to work across campus. When you see these in operation, it's something to behold, because you'll have 3 or 4 students at the moment because of COVID sitting around here, looking down through the screen onto an identical boardroom in Edinburgh or Malaysia, as if they're sitting around the same table.
Exactly. Yeah. And the beauty is, as a lecturer, you can have a full control of the screens and the activity that you want students to engage with. Yeah. So they can separately work on projects or certain tasks, but when it comes to the discussion, you can lock the screen of one of them here, and you can control. It's a very good flexibility. Even it doesn't have to be physically here. As I said,
absolutely. And in the scenario where, Mehdi, we're going to say in the next academic year still have some COVID restrictions, and this spaces like these will really support the kind of global delivery that we have been managing over in the past year, because you will just be able to come into your classroom and people will log in, contribute, irrespective of their time zone, irrespective of their location, and really feel like they're engaging with the class as they are there. So yeah,
I think the good thing is, I'm not saying the teaching. I'm saying activity, or you can capture that as well.
Yeah, absolutely.
So you can capture it for the other students who are not able to join now, like they can access it in another time. So that facility is also embedded within the technology that we're using today. So awesome. This is the typical digital classroom that we have. I'm looking forward to start using it in the next academic year. I'm sure.
I certainly am. I hope you can. It's coming across the kind of enthusiasm and excitement that all staff or my colleagues in EPS are. They're delighted to be able to play with these toys that seem to be very intuitive and so enabling to achieve the different ways of learning and teaching that they've been aspiring to for so many years. So
that's true.
We're going.
Turning off.
I think we're going to leave you now, but we'll see you later in one of the labs upstairs. Yes. And thank you very much, Mehdi. We'll see you then.
No problem.
Thank you. So we're heading now up to the 6th floor, where, as I mentioned at the beginning, is actually where we have the majority of our labs and workshops, and where most of the engineers will spend their time. Okay, so now we are on the 6th floor, where we have most of our labs and some of our fabrication facilities. First things first, I have to put on some PPE, and then we will go for the chemistry lab. So bear with me. Two seconds. Okay, we're here in our first lab, in the chemistry lab, and I want to introduce you to Dr. Vahid, who's going to take us through, well, I guess, how does this particular lab support different courses and students across our curriculums?
Sure. Hello. Welcome to the chemistry lab. So here we run a number of experiments that can support teaching and learning in different courses, like process engineering A, process engineering B, and reaction, separation, any kind of experiment that you need to deal with the chemicals.
Yep.
So we're doing in this lab. So as an example here, we have CSTR experiment, which is dealing with the reaction, and we're dealing with the different chemicals. And then we have it connected to the software that students can work with the software connected to the system. And also we have the hot bath to control the temperature for the chemicals if it's needed. And that's all. I would like to just hand it to my colleague, Dr. Manjula.
This is Manjula, who predominantly teaches chemistry. I suppose principles chemistry, chemical reactivity. Maybe you could run through some of the activities that we do here.
Yes, we do a lot of experiments based on chemistry here in the lab. The first thing I would like to mention is about the induction session that we have. So students are briefed about the safety protocol, the use of goggles, the use of safety shoes, and also about appropriate disposal of chemicals.
Yep.
And prior to every experiment, they have to fill out a risk assessment form, and where they mention the potential hazards and how to mitigate them. And after they complete the experiment as well, they're supposed to sign off the form.
Excellent. So maybe you could run us through, maybe it's just some of the health and safety equipment that we have here that obviously mandated, but so important to keep our students safe in all the activities that they do. I spot in the background here.
Yes. So we have a safety shower here and an eye wash right there. Now we have eye washes across all the tables. So we've got a total of about 4 eye washes. In case they get some chemicals into their eyes, they use the eye wash. And I'll just show you some of the experiments out here. So this is the experimental setup for studying the effect of change in pressure on the boiling point of a liquid. And this is the pH meter out here. Students perform pH metric titrations where they find the unknown concentrations. So a lot of calculations here related to chemical equations as well. And this is about finding the latent heat of vaporization of water related to thermodynamics. And we have a fume chamber here as well. All right. And this is the spill kit. In case there is any chemical on the ground, the spill kit is used, to clean up.
Thank you very much, Manjula. If I could take, well, actually, you might hold on to this for a second. Something that is common to all our labs, I guess, is the kind of the IT infrastructure that we have here, the AV and IT infrastructure that we have here. Maybe you want to take this one. Go ahead.
Yeah, that's a good question. Here, we have a kind of opportunity to have a lecture. If the students are sitting around and they want to follow what we're doing, like instructor can do the experiment on the bench, and the camera is taking it at the kind of sensor. Just if I move as instructor everywhere, it's just following, and I can do the experiment myself, and students can see on the screen, 2 screens on the back and here. They can see the procedures and everything, because we need to do a kind of introduction at the beginning, going through the manuals.
Right.
And then students get familiar with what is the concept behind each experiment, and then they do it themselves to learn. So it will be just a kind of technical, already here camera, and I do it on the bench, and then I just go through all the benches, and students can do it themselves. So that's the technology. We have it all around. If I move it, the camera takes it everywhere.
So we anticipate, obviously, with this new facility that we will be delivering, a lot more perhaps of the lectures, tutorials, even in the space, the kind of the experiential learning that perhaps more of it was in labs, it was in lecture theaters and in classrooms before. We'll be able to do more here, as well as obviously doing our health and safety briefings from here. Excellent. And of course, as part of our responsive blended learning and our online provision in the past, we've had to do a lot of recordings. With each learning space has one of these recording cameras, so we'll be able to lecture capture just about every second of the curriculum.
Yeah, specifically during the pandemic, if there is something coming up, if you want to do the lecture online, that would be a good facility showing at the same time the experiment to the students, support them if they're following and doing online.
Awesome.
Yeah.
Thank you very much. Thank you both. And we'll move on to our next step. Thank you, Manjula. Thanks, Vahid. Okay, so our next space that we're going to go into now, I can remove these, is our structures lab. And I think we're going to be met here by Rehan again. So we've met Rehan before, and he's going to take us through, I'm going to give you this, keep it close. He's going to take us through how the structures lab in particular is used to support different parts of mostly the mechanical engineering undergraduate curriculum, right?
Thanks, Ty. So welcome to the structures lab. So in this lab, we teach most of the strength of materials related activities and structure related activities. In particular, I would like to draw your attention to the tensile testing machine, which is used to test 2D frame structures, which the students fabricate in the fabrication lab, which you will be seeing later on. And this is part of the Mech-Eng in Context course in year 1. The rest of the lab is used mostly for final year project students and for supporting our teaching and research integration activities. So we have different types of equipment here which the students use as and when it is required.
Okay, and again, kind of like what we had in chemical engineering, as I said, or chemistry, it's going to be common to all these spaces. This looks like a lab, but it's a teaching space as well. You can conceive.
Indeed, it is. It is a teaching space, and as you can see, it's got a projector up there, and it's basically following. So it's like a smart system, which is well connected and integrated for teaching purposes.
Excellent. Thank you very much.
Thank you.
We'll take it from there. Thank you very much, Rehan. And I think we'll see you later as well. Thank you. Thanks, Amber. Okay. So one thing that was really important to us as we were kind of designing this facility was to design spaces that weren't they weren't unique to any particular program, but they were designed for the particular activity. So it's very conceivable that a student would be using the electronics lab, for example, if they're a mechanical engineer, using the robotics lab as a chemical engineer. So we'll see that as we go now into the electronics lab, which again is something that supports all our engineers. It's probably one of our strengths here in Dubai that because we offer so many different types of engineering or different programs in engineering that the facilities benefit all of them. So let's go into the electronics lab. Hello, Siri again. Hey, Tanishi. So Suri, who we met before in the maths gym, if you take that, just keep it close. It's okay, just fine just there. And maybe you just want to talk us through what this facility is used for and how students are supported in their curriculum, probably more towards the electrical and electronic degrees, but also maybe robotics, autonomous, interactive systems.
Welcome to electronics lab. Here, basically, we are starting learning by doing activities. Our school strategy is learning by doing. To support that, we have so many courses. Like in the year 1, we are having a course called Intro to EN Circuits, which is common to all students except chemical engineering, electrical, mechanical, automotive. All students are learning that course, and we are giving them the project. This is one of the projects which was accomplished. A prototype card reader. They are studying digital and analog systems. Okay, after studying, in the 6th week onwards, they are carrying out this project, and they are building the prototype card reader, swipe card. So, and in the first year, second semester, we are having Praxis Electronic System Design course, wherein they are practicing with soldering and as well as they are developing FM radio. And in second year, first semester, we are having a course called Circuits and Analysis, wherein they are familiarized with AC circuits and series parallel circuits, resonance circuits, and all those things they are practically doing. That is called learning by doing. And in the second year, second semester, we have electrical machines and power course, wherein they are using Arduino to control small motors and stuff like that. And third year, we are having a course called as electrical energy systems. These are all the single phase transformer, and this is induction motor, 3-phase induction motor coupled to the DC generator. And third year, second semester, we are having system project, which is equivalent to 2 subjects, wherein they are building a robot. Last year, we have given robot for entertaining children in the theme park. So they are building complete robot using FPGA boards, and they are learning about sensors, how to interface, and all those things. At the end of the day, they are building a complete product.
Yeah, and it's kind of that, we see it in our students all the time. It's by giving that challenge and that sense of achievement, we find that they're, they learn much more than sometimes the confines of the curriculum. It's just sometimes about empowering them, isn't it?
Yes, exactly. It is not limited to that. And they are also learning what is known as time and frequency of the signals, wherein they're using this DSP board, ARM processor board, and it is also used in 4th year level course called DSP.
Excellent.
So,
thank you very much, Suri. If you could maybe just run us through then the facility here. So these kind of 2 desks together, if you could pan back a little bit, Febin. These 2 desks together we would consider a workstation, right? And I see from fairly standard equipment here, oscilloscopes, power supplies, solder station, etc.
Everything is there, whatever they want.
So these 2 desks together we would consider a workstation, right?
In addition to that, there will be a computers here.
That's right,
So where they can use the programming. So for example, if they are using with FPGA board, they can use Verilog programming. They can do it and they can interface it.
So as you'll have heard me say already, we're still moving in here. There's 20 computers to be installed here that will obviously form the rest of a typical workstation that students, and they might get together here in groups, obviously socially distanced, but we're aiming at about 3 to 4 people would typically be working on a project together in a kind of this workstation of 2 halves.
Good. And we have here empty space. Basically, why we have kept this one is for the final year projects. I'm going to show you one of the final year project, undergraduate project, which was sponsored by Expo Live University Innovation Grant Program.
Yeah, so just a couple of things on that. I know this discipline, and you in particular, have been very successful in attracting kind of small pots of research or industry-led projects. This is one I think you do with Phoenix.
Yes, exactly. So this complete is an industrial project.
Yeah.
It is sponsored by Phoenix Contact of Germany, and they have sponsored all these PLCs,
Yeah.
and also the power supplies, and also the relays and various systems.
Yeah.
Basically, it is for solar panel cleaning and cooling system, and as well as it is capable of charging two 24 volts lead acid batteries.
Yeah.
Okay, so these are this is completely sponsored by Phoenix Contact and as well as Expo Live University Innovation Grant Program.
Excellent, thank you very much. And that kind of, that links into what Muhsin was talking about earlier with our Industrial Advisory Board. I know Phoenix are part of our Industrial Advisory Board, and they really help to keep, they hire some of our graduates, and they really help to keep the curriculum really contextual to the local market here. So can I introduce you now to Tanishi? So Tanishi is a graduating student this year, hopefully first class honors, or fingers crossed, and, and the school officer for EECE. And you just wanted to maybe just give us a couple minutes on the project and that you did, and maybe how you have used spaces, not always this space because we've just moved into it, but the equivalent space in our interim campus and previously when we were in Academic City.
So due to the COVID regulations that were applied this time, all our projects were meant to be dry, but I did still receive a lot of support.
I'm going to stop you there. Dry. So dry means that it was kind of going to be paper-based, doesn't it? As opposed to something that was, I don't know, physical design and build. Right, okay, sorry.
So everything had to be done on your paper, no practical work as such.
Yeah.
But I did still receive a lot of support from the university to get some kind of live reading.
Yeah.
So I was able to come to university and pick up the Arduino kit.
Yes.
Which came with an Arduino Uno, a couple of connecting wires, and resistors. I was also provided with the sensors that I would have needed for my system.
Yeah.
So my project was based on vertical farming and hydroponics.
Yeah.
And using these components, I was able to get dummy readings for my Arduino, which would then pass on the information, relay it onto the PC, and would take action accordingly. So even though we had a few restrictions and we weren't able to do as much as we would, the university was still able to support us to produce the best possible.
Yeah, so that was, that was one of the biggest challenges we had over COVID, was to still kind of put in that kind of practice-based learning part that is so important to engineers, but particularly I would have said to the Heriot-Watt engineer. So we, through our Learning and Teaching Academy, we had this, and we came up where we could to be able to supply. And I think what we supplied were these kind of kits to all of our first and second year students, and then obviously individual project students who were able to benefit from it too. So glad to hear that you benefited from that too. And thank you very much, Nishi. Yes, you wanted to mention something on, what was the competition?
Yes, so I think the most rewarding part of this entire year and my experience was being able to participate in the EEG Inter-University environmental competition. Yeah. So I participated in the competition with my team of Olga and Priscilla Jayachandran. And with the support of our supervisor and the university, we were not only named the winners of our category, which was resource efficiency and climate change, but were also announced as the overall champions. And we all just spoke about our final year projects, and they were really impressed to see engineering students, female engineering students.
True that. It was three female, yes, in one group.
Engineering students, just talking about our work and how we would like to help the world one day.
Yeah, awesome. No, that was a really good achievement on a national level as well. So it was really, really impressive.
We had teams participating from all over the MENA region.
Yeah. And I think adding to your list of success is Surrey as well, right?
I want to share one more.
Please.
Good news for this year's project, and one of the industrially sponsored project called EGA sponsored.
That's right. So EGA is Emirates
Global Aluminium Company, wherein we are supposed to build a drone which is capable of capturing aerial image of their aluminium baking furnace. And during baking, the pit walls may expand. They have some categories. We have to categorize it. The drone should take the aerial imaging picture, and we are going to use computer vision algorithm we have to develop, and it has to calculate the pit widths. And I'm very pleased to inform you that we got the second place.
Yeah, it was pretty awesome.
Yeah, thank you.
Thank you very much, Surrey. Yeah, thank you very much, Nishi, and we'll catch you again later. Thank you. Okay, so we're going to now move to our robotics lab. Now, this is a new facility. And it is, of course, to support our new degree program in robotics, autonomous, and interactive systems. But you'll probably hear me saying that this is something that will also support students irrespective of their engineering discipline, and even beyond that. And I keep doing that. Okay, so hi, Mohammed. I'll give you this as I quickly introduce the space here. So as I said, this is our robotics lab. It is my favorite part on campus. It probably has one of the best views that in Heriot-Watt, Dubai. I don't know if you can see it there, but that's the Burj Khalifa. You can see the Burj Al Arab. And if you pan across to the left-hand side, we're looking over the Palm Jumeirah. We're on the 6th floor of our new campus here. This is where we're going to do anything to do with robotics, automation, artificial intelligence. All of that is going to be here. And of course, it's going to be important to our new program in robotics, autonomous interactive systems. But we're very excited to see how this space will also benefit our manufacturing, our chemical engineers with process control, and pretty much every discipline that we have here. It is, we'll admit, quite sparse at the moment. So I'm going to introduce you again to Mohammed Al-Musla, who's going to take you through the plans. We have an investment this summer, so over the next few months, of about 800,000 to $1 million dirhams. So that's the equivalent of maybe 200,000 pounds for new equipment that's going to support the activities in this room. So I know you've put a bit of a presentation together, so maybe you can take it from there.
Thank you for that. So in the future, this place will be activity-based for robotics. Whatever robotics is going to take place here. We start with some basic robotics with kits where the students, they can get their hands on and practice different control algorithms and functionality. We are choosing these very carefully to make sure they are compatible with the main platform like ROS, MATLAB, and whatever development platform they might use. Here, for example, the Turtle Boat, autonomous with LiDAR and ranging camera. These selection also allow us for some remote sensing and ranging capabilities. Ground vehicles, autonomous driving, and here's automotive engineers, mechanical engineers can come together with robotics and electronics to build system from scratch. They start here basically with some basic kits that some of them we built in-house. They put together using kit of parts, and then they move on to more commercial and I would say also industrial size robots like the one you see behind you there.
Yeah, we'll take a look at that in a second. It's just as you mentioned it there, Formula Student again, we saw earlier in the workshop, Heriot-Watt Racing there, that has gone through an evolution over its time. It started obviously as a typical IC engine, and now it's moving to an electrical drive. And the plans are in future for us to go to have an entry for the autonomous competition as well. So again, this is how this space.
This is where they will start here, working with LiDARs, ranging cameras, and then they get all working as a system, fit it down in the car, and get it rolling. And that is already being discussed with some final year project of students currently working in and preparing the grounds for the future.
Absolutely, and obviously robotics for Heriot-Watt is one of our strengths with the National Robotarium in Edinburgh. You mentioned him already. This is Popeye, indeed. Tell us more.
For any robotics to work well, it really needs to be engaging with the industry. Robotics everywhere, doing lots of functions within the industry today. So we are working in collaboration with multiple entities. This, for example, full-fledged industrial robots from high-tech automation. We work with other partners, and the main thing is to allow the students to have some hands-on on such industrial system before they go and see them in reality.
I'm always impressed by Popeye because he looks like a brute, but his speed and what would you say, accuracy is incredibly impressive. So we won't see him in action today, but maybe we can provide some videos for that as well. Exactly. Thank you very much, Mohammed. I think I'll see you later in the Innovation Hub. Thank you. Okay, so leaving the robotics, this is a bit of a flying whistle-stop tour of our facilities, but we're about to go into the energy lab. And I always have to look to the, thank you very much, nearly forgot. Hello, everybody. I'm so glad that we're getting the opportunity here to also meet so many of the faculty of the School of Engineering and Physical Sciences. Unfortunately, they can't all be here today, but I really did want to take the opportunity for them to express, how they contribute and how the facilities contribute to the, the different courses that we deliver as part of our programs. I think we're going to start here with Mehdi, who we've met already, but Mehdi has established, we were just talking in the last lab about some industry collaboration. And I think it's good that you kind of take it forward with the work that you've done, the relationship you've built with Wilo over the past. So maybe you can tell us what the plans are.
Yeah, exactly. This is one of the examples of our industrial partnership that we have. Obviously, you don't see anything at the moment in this side of the lab, but our partner Wilo company is a pump company that they're sponsoring to build a sort of miniature version of their Wilo Academy in this side. So it's going to be from this side of the wall up to here. It's going to be all the latest technology that they have. And as you can see over there on the screen, this is going to be this is a Wilo Academy that they have built. A miniature version of this type is going to be built here by September, hopefully before the students join us. And by the next academic year, they can actually use this facility. It's going to have various sections. There's a section for testing. So, for example, cavitation testing. There's going to be a section for students to be able to see the latest technology in the pumping industry, submersible pumps, for example.
Sure.
And so, yeah, this is a mixture of various things.
But worth pointing out, this isn't a future relationship. This is one that we've had with Wilo for many.
This one is through the memorandum of understanding, which was started about 5 years ago.
Yeah.
And this is a continuation work that we have.
And in our academic city campus, the previous campus, we also had an installation of their latest and greatest at the time.
Exactly. So we had that as well there, which was the Wilo pump. And this one is different because it's going to be now a bit more advanced.
Yes.
They're bringing more advanced technologies here for us. But no, this is a sort of already established connection that we had with them. And
I mean, we kind of, as we were at the design stage of this building and how we were going to outfit, we were very cognizant of the leaving space for Wilo
Yes. So that was already dedicated for them to place their miniature Wilo pump.
Thank you very much. So, we've mentioned already how this is kind of, our labs are set up based on activity. So we're in the energy lab here. You will see lots of fluid mechanics, thermodynamics, process that Nazir is going to talk about in a second. I'm not going to forget dynamics this time. So maybe I'll just introduce you now to Nazir. Nazir is our program director for chemical engineering. Oh, chemical and process engineering. Yes, but you oversee the degree program in chemical engineering.
Yes.
And you might run us through just some of the activities that students do here.
Yeah, actually, if we look in any chemical process, we have like what we call multi-layers. The core of it is chemical reaction engineering, which I believe you've seen it in the chemistry lab. We have a set for a CSTR. Then we talk about separation processes.
Yeah.
One of them was the distillation column, also in the chemistry lab.
Filtration.
Here we have the absorption column. Yeah, part of it now because we are still in the process of building it. And then after that, we are looking about different utilities. Heat transfer, we have heat exchangers there, and of course here. And also we have a fluid mechanics in the other part of this lab where Dr. Rebecca will talk about it.
Yeah.
And of course, to hold everything together and make sure that we are keeping the safety of our staff, of our equipment, of our process, we need process control. So for example, this is even that it's very simple, it looks, but it's actually very, very comprehensive set of process control trainer, where the students can learn a lot of different types of control actions, control processes, connection, different equipment, pumps, heating
boiler
vessel. We have we are thinking about recycling, cavitation. They can check that sometimes there will be cavitation, where then the process control starts shutting on and off. All these actions, they can see it actually in front of in front of them.
That's great. That kind of links really well to what we were just saying in the robotics lab, because we were saying, robotics isn't just robotics in isolation. It's kind of that automation, it's that control, it's that will feed into our chemical engineers as well. So we obviously hosted here because we'd consider this lab to be a kind of a wet area. But the kind of the fundamentals of process control would also be supported by the robotics lab, right?
Yeah, and that's one of the items of chemical engineering is machine learning.
Yes.
Because we want also the machine with time, with the different actions in the process, start learning what should be the proper control.
Also things that happen in our electric and electronics labs.
Of course.
Excellent. Thank you very much, Nazir. I think you're going to pass that on to me, over to Rebecca. Hello, Rebecca. Rebecca is an assistant professor in chemical engineering, I always think, but I know you contribute also to the undergraduate programs in mechanical and energy and automotive engineering as well. And you want to run us through maybe some of the fluid mechanics, I would say.
Yep. Sure. Yes. So the one here we have seen here is the wind tunnel. So this wind tunnel is mainly for the students to run the experiment, undergrad, year 3 students or mechanical students.
Excellent. So we're looking at things like, I don't know, measuring drag and lift and different.
Definitely, yes.
Yeah. What I like about this is that we sometimes do like 3D printed aerofoils or whatever, and they're able to go from the concept on the page to something physical.
True.
And then
try it on.
Right. And then we bring in the CFD that I'm sure Mehdi over there has loved to talk to us about, but I'm not going to right now.
And
so
what we have here is another equipment where students look into compressed fluid, and they can look into the subsonic as well as the supersonic flow and how they differ in terms of properties and so on.
Right.
Fluid mechanics experiments where the students look into instrumentation. These are the flow meters where students look into sensors, instrumentation, and this is the fundamental for them to move on into their later courses in process control, and we have hydraulic benches as well. So these are fundamental year 2 experiments.
Excellent. Thank you very much for that, Rebecca. I guess it's worth me pointing out here as a kind of an overview. This lab can look a little bit condensed with all that equipment. You can see the air conditioning, psychrometry units, heat exchangers, and all these hydraulic benches up together. That's actually the equipment in storage. So these, in practice, this equipment will be commissioned. It'll be put into place, maybe fluids added or taken away or cleaned, put into place for the 2 or 3 weeks when it would be used throughout the year, and then put back into its home. So yeah, just thought it's worth pointing that one out. I think we're going to come back now with Amber. I'm going to give this to you, and you're going to run through maybe some of how we support the dynamics part of the curriculum in mostly mechanical engineering. And Amber, by the way, is an assistant professor of mechanical engineering.
Right. So like Tags just said, in this lab, we also support, in addition to our fluid mechanics courses, our strength of material course, which I'll show you here, rigs particularly for the torsion experiment, which we do in the second year mechanical strength of materials A course. And we do that along with a deflection experiment. And that's what we use to support, to demonstrate the concepts of deflection and torsion. Along with that, we also do support dynamics, the dynamics part of the course, which is Dynamics A. And we do that for the range of the years from the second year to the third year to the fourth year. And in this corner here, what we would have is a simple experiment for wheel and axle. For a second year experiment, which is Dynamics A. We also have a 1 degree of freedom vibration experiment here for the third year experiment. And we have a free vibration experiment set up here, which is for the fourth year, which is B51EO. And just to mention this also, which I'm sure Dr. Rehan would have mentioned, just to show you for there, we also have, for the research engagement support, we have his friction and wear experiment for tribology experiment set up here, which is used for final year and research activities as well. So that is how we support these courses with the machines we have here.
Thank you very much, Amber. I think you're going to come with me as we leave this energy lab, and we're going to go into one of our fabrication labs next door. So I have to press the button here. And I think it's open, but normally we'd have to swipe card access. And I'll just introduce this area very briefly, but as I said, it's a fabrication lab. It's a bit different to what we had in the workshop area. It's just kind of different activities. It's perhaps lighter equipment that we were able to bring up here, and it's ones that generally need more exhaust. It's a high PPE area when it's in operation. And yeah, Amber, maybe you could tell us how this takes the student from the first year and how then it's, supports the curriculum as you go up.
Okay, all right, so this is the fabrication lab as Tag has just introduced here, where we can see a range of machines going from the laser cutters all to 3D machines to benchtop drilling machines. Along the way, we can see bench vices with basic workshop tools here, which we use to...
we'll just pause it a little bit just as we pan around. What we have here are these benchtop CNC machines. So what do we have? We have milling and a lathe.
Yep, the lathe milling.
To just presses.
Okay, and yeah, we have the presses.
Drill press.
Here. And then on the tables here, you would see different workshop tools from scribers, rulers. We have saws, hammers, and bench vices that we use to support this. And like Tag says, we support, it's a high PP area, which is always under strict supervision. So you have to have access here, and we support from our first years, starting with from their workshop process where they learn to use these tools, as well as where they do their first 2D frame in the engineering context course, which they design a 2D frame from an aluminum material. They're riveted together based on some theoretical designs they carry out, and then use pin joints, and then they test these pin joints in the tensometer, which was shown earlier to you in the structures lab.
So this is first year stuff. It's very early days. They get in some, what would you say, manual handling or tool workshops. That's the mandatory part of the course, right?
So they have one section which is dedicated to them to teach them how to use the course,
right?
And the second part allows them to use that to produce their very first 2D frame,
right?
Which is tested against a tenth of, I think, 2,500 newtons.
Okay. But they're generally tested to destruction. And
so they won't see the point of failure. So the maximum we should be able to withstand is 2,500.
Okay. And then as we go through the curriculum, I mean, we're not making mechanics here. They're not, it's not mandatory that they become experts in the use of all of this equipment, but it is possible through extracurricular tuition or extracurricular training that they would be able to operate some of these equipment independently.
Yes, so we also, we support D&M again, where a lot of the students are
D&M, design and manufacturing.
Design and manufacturing courses. I do apologize for the...
That's all right.
And so students are allowed, like Tag said, they get trained on this, and they're allowed under supervision to carry out projects that could be of interest to them.
Yes.
Right? So we try as much as possible to encourage them, but it's an area that we always want to make sure that they work very safely and they are able to experiment this in very safe environments.
Awesome. I'm going to take that, and I'm going to thank you both for your contributions, and I'll see you later. Thank you very much. Okay, so we're coming towards the end of our tour here. We're leaving this fabrication zone here. We're going into a through and through office, I think we call it. I always get this wrong. So this is where our technical team sit. They're a pool resource for the whole school. They have oversight when things are not so busy of all the activities that would happen in this fabrication lab, and also looking into, on the other side, the room we're about to go into our innovation hub, which is a very low PPE zone. In fact, I'm going to take mine off as we go in. Okay, so I need that. Push. Okay, so this is an exciting new, I would say, venture for the School of Engineering and Physical Sciences. We're back with Mohammed Al-Musla, who we've been working on this kind of concept for a little bit of time. This is what we're calling an innovation hub, formerly, or perhaps an evolution from what we used to have of a maker space. And we're very keen to point out that it's not a lab. It's one of the only rooms on campus where, I'm right in saying that we don't have any flat screens, we don't have any cameras. This is meant to be more of a, would you say, hangout zone?
Yeah.
So maybe you give us a couple minutes of what how this supports students inside and beyond the curriculum.
Thank you very much. To start with, this is a low-risk area, so we have selected the equipment to be here very carefully, so it couldn't be user-friendly and students can use them with little experience. The space itself provides the students with some surface area for them to start and draw, design, think loudly with their colleagues, and then build up on their concepts from a concept, then quickly, rapidly prototype it using the 3D printers, the vacuum former, and the other equipment available here to come to reality. And I think this links really well with our enterprise hub, where the students then can think of not being students anymore, being the boss, and getting into startups, talk to clients, provide solutions, and so on. So this is really what this space is about. Lots of space. They are free to use it in any way they want with very little PPE, if any. And of course, good coffee.
Very important to innovation and inspiration. I guess what we were really keen to do in this space, and we're probably not there yet, is to make it really welcoming to non-technical people. So while it is, I suppose, nominally under the charge of the School of Engineering and Physical Sciences, we're really trying to encourage in students with business backgrounds, with social sciences backgrounds, marketing, all the things that make a project successful, to make those kind of interdisciplinary projects and enterprises that have the potential to be the next innovation of the future. So whereas this room here, the technical hub where they're perhaps going to create the first prototype or process or service or whatever, downstairs, as we saw in the enterprise, that's where they're going to get more of the business support, maybe the legal support, maybe just the environment support that will help them and nurture small enterprises. And while this, I suppose I would consider this something that isn't directly embedded in the curriculum, it's something that is very important to the university. And this is the contribution, I suppose, the School of Engineering and Physical Sciences plays to that kind of university strategy or that university emphasis.
We do encourage students from any school to be here. We encourage them also to build multidisciplinary groups because a successful project, a successful idea really needs talent from all these different aspects. It's not only the engineering bit of it, because you will need to sell it at the end of the day. And so
absolutely. And while we have a course in business awareness, safety, sustainability, we have those courses, so it's mandated in the curriculum. It's that challenge really to always tell the engineers or to inform engineers that for it to be successful, it doesn't just have to technically work. It has to be marketable, it has to be affordable, it has to, and all of that I'm sure we're all well aware. And that's what makes what we think engineers really solve real world problems.
Absolutely.
So that brings us to the end of our tour. We hope we've given you some insight into how our facilities, how our staff, how we've designed our courses and our curriculums, develop the graduate attributes of a Heriot-Watt engineer. This has been a labor of love for the past few years, and we've started with a pretty close to a blank palette, and we've been able to put in what we want, and we've been really happy with how it's shaping up. As you've seen through the tour, we're not there yet. We literally moved in here 4 days ago, officially opening our doors 4 days ago, and there's a lot more to do. We hope to give you some insight, not just into what it is now, but what it will be in the future. And we're really looking forward to welcoming our students back, hopefully post-COVID, in a new campus from September 2020. We hope it's going to be really busy. Okay, thank you for this, and obviously we look forward to interacting with you in live session in the next few weeks and months. So thank you.
Thank you.